So in the previous video, we've seen that whenever you have a difference of two logs, so when you have one thing, take away another thing, it's in effect x divided by y. So in this video, it's your turn to have a go. Your task is to try and prove this. Whenever you have log base a of x, and then now it's plus log base a of y, that becomes log base a of x times y. So in the previous video, we've proved this. So now it's your turn to have a go. Your task is to try and prove this. Okay, but before you do this, try and understand how we did it last time. Last time we would try to rewrite this number here, x, as one thing to the power of another thing. So rewrite this number here as this number, and rewrite this thing here, this y here, as this thing here. And then once you've got this, you will automatically get this. And then once you've got this here, you will automatically get this. And then start from here. And then pretty much put this into here and put this into here. So start with this and somehow slowly get to this. Okay, so watch how you did it last time, and use the same process to prove the sum of two things. Okay, so this was how we did it last time. So last time we would rewrite this as this, rewrite this as this, and then we will automatically get this. We will automatically get this, and then use the laws of indices here to slowly get from this x over y here, this x over y to this. Okay, so look at this here, from x over y here, and then slowly move this, somehow transform that into this. Okay, well anyway, this was last time. I'm just going to go scroll through last video's proof. So that would take us, this is the final proof. But now it's your turn to have a go now. Your task is to hang on. Your task is to prove this. Okay, so the trick here, remember the trick here is to rewrite the x as a to the power of blah blah blah, and then rewrite the y as a to the power of another blah blah blah, and then put this into here, and then put it into here. Remember, when you have this thing, you'll automatically get blah blah blah, and then somehow slowly transform this into this. Well, anyway, press pause and have a go. Okay, so to prove this here, rewrite the x as this, rewrite the y here as this thing here. So once you have this here, you will automatically get this. Once you have this, you will automatically get this. Okay, so now looking at this here, you've got x times y. So looking at x times y, well, if you have x times y, then because x is the same as this and y is the same as this, if x times y, that's the same as this times this. So basically, we're going to get this times this. So this times this. Okay, and then by using laws of indices, this then will become that, and then when you're here, and then deliberately log base a to both sides, so that later we'll cancel this out. So when you're here, deliberately log base a to both sides, so that would give you this. So basically you log this thing here, and then you log this thing here. And then remember, one of the laws that we use is that if you have a to the power of something, if you log it, then this thing goes out here. So that's why you've got, well, at the moment here, you've got a to the power of this bubble here. So when you log it, this moves out here. So that bubble there is in effect this bubble here, and then log base a of a. So from here you would then get to here. Okay. So here, looking at this, you've got one thing multiplying another thing, and then this thing here is really 1. Okay, this thing here is 1. So you've got this block multiply with 1. That would just leave you with n plus n. So this thing here will then become this, because this block here is just 1. Okay, so that will then take you to here. And remember from earlier, So now we're at a stage where you have m plus n. So if you look from earlier, whenever you have this here, you will automatically get this. So don't forget, this m is this thing here, n is this thing here. So let's just substitute them in. So m is this thing here, and n is this thing here. So now you've got, whenever you have this log plus this log, is in effect the same as x times y. Okay, but make sure all the bases are the same. Okay, so that proof done.